In this video, we're going to apply the substitution method to solve a few more indefinite integrals. So here we have integral x divided by 4 minus x squared plus square root of 4 minus x squared integrated with respect to x. We're going to let u be equal to the inside function 4 minus x squared. Its derivative du is going to be equal to derivative of 4 is 0 and derivative of minus x squared is minus 2x. So minus 2x dx. And let's divide by negative 1/2. We get minus 1/2 du is equal to x dx. Let's rewrite the integrand in such a way to make the substitution easier to see. You have 1 over 4 minus x squared plus square root of 4 minus x squared times x dx. All right, this part of the integrand is going to be 1 over u plus root u. X dx, this part, is going to be negative 1/2 du. We can now get everything in terms of u. So we have integral negative 1/2 times 1 over u plus root u du. Negative 1/2 is a constant, passes through the integral. We get negative 1/2 integral 1 over u plus root u. We're going to need to do another substitution. So we have negative 1/2 integral 1 over u plus root u. What is the choice for t? We're going to let t be equal to root u. dt, the differential dt, will be 1 over 2 root u du. Solving for du, we get du is equal to 2 root u dt, but root u is just t, so we get 2t dt. That's du. So du is equal to 2t dt, and t is equal to root u, and t squared is equal to u. All right, so what we have is negative 1/2 integral 1 over u is equal to t squared, so I can just write this as t squared plus root u, that's the variable of substitution, that's t, and du is going to be equal to 2t dt. That's 2t dt. The 2's cancel out, and we have negative 1 integral t divided by t squared plus t. You will notice there is a common factor of t in the numerator and denominator, so we can just divide by t and get rid of that factor. Divide by t, and divide the numerator by t, and we're going to get negative 1 integral 1 over t plus 1 integrated with respect to t. And this integral is going to be log minus log of t plus 1. That's the antiderivative of 1 over t plus 1. Notice that I use a shortcut here, 1 over ax plus b, integrate with respect to x. This is equal to ln of absolute value of ax plus b, divided by a plus c. All right, now, so what we have here is negative 1 over t plus 1. The integral of this is equal to minus log of absolute value of t plus 1 plus c. But recall that t is equal to root u, and u is equal to 4 minus x squared, because we're doing a double substitution here. So let's return to the original variables. So minus log of t is root u plus 1 plus c, and that's equal to minus log of u is equal to 4 minus x squared, that's root of 4 minus x squared, plus 1 plus c. And since everything is positive, root of 4 minus x squared is a positive number, and plus 1 is a positive number, we don't really need the absolute value. In fact, we don't need it, so we will just write as minus log of root 4 minus x squared, root 4 minus x squared, plus 1 plus c. All right, so what we have shown is that the integral of x divided by 4 minus x squared plus root of 4 minus x squared integrated with respect to x is equal to minus log of root of 4 minus x squared plus 1 plus c. All right, so that was using double substitution. So we had to do two different substitutions to arrive at this answer. Let's look at another example of this type of substitution. So here we have integral 2x divided by e to the minus x squared plus e to the x squared integrated with respect to x. We're going to let u be equal to x squared. Its derivative du will be 2x dx using the power rule. And so now let's rewrite the integrand in such a way to make this substitution easier to see. We have e to the minus x squared plus e to the x squared, 1 over all of this, times 2x dx. All right, so we can rewrite this as 1 over e to the minus x squared will be e to the minus u, because u is equal to x squared, plus e to the x squared is going to be e to the u, and 2x dx, this part is just a differential du. Now we need to do some algebra on this before we can solve this. So what we have is the integral 1 over e to the minus u plus e to the u. Let's get rid of the negative exponential by multiplying top and bottom by e to the u. E to the u divided by e to the u. And we're going to get integral e to the u divided by e to the minus u times e to the u plus e to the u times e to the u, integrated with respect to u. So what we get is integral e to the u divided by e to the minus u times e to the u. The bases are the same, so we add the exponents and we get minus u plus u, that is 0. So we get e to the 0, and e to the 0 is 1. So 1 plus, and in this case, e to the u times e to the u, the bases are the same. We add the exponents, we get e to the 2u. All right, integrated with respect to u. We're going to need to do another substitution. All right, so what we have is integral e to the u divided by 1 plus e to the 2u du. We're going to let t be equal to e to the u, and dt is going to be e to the u du. So what we get is 1 plus, let's rewrite this as e to the u all squared. Let me fix that here. All squared times du times e to the u du. And that's going to be equal to 1 over 1 plus e to the u, that's our substitution t, 1 plus t squared. And e to the u du, that's going to be dt. Let me write that neater. This is 1 plus t squared. What is the antiderivative of 1 over 1 plus t squared? Well, that is just arctan of t. So the answer is tan minus 1 of t plus c. But now we have to return to the original variables. We know that t is equal to e to the u and u is equal to x squared. So let's reverse everything. So we get tan minus 1 of t, which is e to the u, plus c. And now place u back in, we get tan minus 1 of e to the x squared plus c. So what we have shown by using double substitution is that the integral 2x divided by e to the minus x squared plus e to the x squared integrated with respect to x is equal to tan minus 1 arctan of e to the x squared plus c. This is the answer. All right, thanks.